Cool, thank you very much. So, my name is Robert, and today I will show you how domain-driven design can simplify your Go project. At the beginning, a couple words about myself. So, like Miłosz, I'm co-founder of Tridos Labs, what a coincidence, and today we went specially for you from Krakow by train. That was pretty long journey, but we did it. And yeah, today I will talk about domain-driven design. And you may know me from Tridos Labs. Actually, out of curiosity, have you had the chance to read at least one article on blog or maybe some ebook that we have? Because research. Okay, a couple of you. For the rest, I recommend that to check that. At the end of the presentation, it will be also QR code for the presentation materials. So you don't need to make pictures or whatever. It will be QR code and it will be everything there. And yeah, in Tridos Labs, we are writing about some stuff, but mostly about writing Go services that are maintainable in long term. So yeah, I can say that I'm kind of interested in understanding what we can do to make our lives easier by implementing services that are maintainable in long term. Oh, I can hear myself from the laptop. Oh, yeah, it's fixed. And during over a decade, when I was working as software engineer, most of the time I was hands-on engineer, but I used to be also manager and founder. So I've seen problems of project becoming developer nightmares from multiple angles. And one of the biggest issues that I noticed that projects had was complexity. And I'm not only saying about the accidental complexity that is created by over-engineering stuff. I'm also saying about the essential complexity. So this is the complexity that is related to the natural complexity of each feature that we need to support. So it can start with some simple validations like, I know, price cannot be negative, and on hundreds of regulations enforced by the law. The bad news is if you try to ignore the essential complexity, you can end up with more accidental complexity. Example, so for example, if you try to build a complex financial application like a CRUD, you will end up with a lot of accidental complexity because it cannot be just built in the simple way. And let's now imagine a fictional company. Let's name it BillingMate. So I'm pretty sure that many of you will be able to relate to this company on multiple levels. So BillingMate is creating an API that people can use to issue invoices, take payment for those invoices, and stuff like that. And when the company was starting, more or less 1 year earlier, they were able to deliver one feature more or less weekly. Now, after more than a year, the very similar feature takes more than a month. And it looked that it wouldn't be better with time. It was starting to be worse and worse. The bad news is that their competitor, and yeah, it started to trigger some awkward questions like 1 year ago, implementing such feature took a week. Now it's taking 2 months. What's happening? And this question was pretty on the spot because, companies are not living in the void, and they have a competitor named Invoice Invader. An Invoice Invader was taking more and more of their customers for a very simple reason. They have more features, and they were able to deliver those features faster. So BillingMate needed to find a way to start to deliver stuff a bit earlier. So what's one of the most common solution in these cases? Let's hire more people. And that's what BillingMate did. They hired more people, onboarded them. Did it help? Well, unfortunately not. Actually, development with those new people was even slower. So probably hiring even more people will not help there. But fortunately, one of the new joiners had a brilliant idea that I'm sure it's because our application is monolith and we need to split that. And it was the beginning of the project under cryptonym Migration to Microservices and Kubernetes. Probably I can spend another hour what can go wrong here and why it's not a trivial thing, but probably don't have entire night, so let's just assume that they succeeded, they have Dream Kubernetes cluster, everything went well. But how about delivery velocity? Unfortunately, it was even worse than it was at the beginning. So they needed to find another solution for their problems. One of them person started to say, it needs to be like that. I've seen it in every company. And okay, it's a very convenient excuse that I heard multiple times in my life, but is it really true? And Billing Invader was taking more and more of their customers, so they needed to find out something, because this excuse, well, we can have this excuse, but company is dying, so we need to do something about that. And let's now meet Emily. So Emily also joined the company in one of the hiring batches, and she worked in a similar company earlier, and she was kind of surprised. Why it's taking so long to implement features in this company? Because she's seen that, okay, implementing such features should be much faster. So she started to do some small investigation to understand what's wrong here. So she took an example of a credit note, so implementing a credit note functionality. I'm sure everybody knows here what credit note is. Okay, I look on our faces, not. So I will just give you now accounting course for 30-second accounting course for free now. So look, so this is how the typical invoice looks like. Probably most of you seen an invoice in your life. Fortunately or not fortunately, probably most cases fortunately. And you can see that there is an invoice, it's issued from somebody to somebody, and you have invoice positions in this invoice. It's everything great, but well, shit happens and you can make a mistake in this invoice. And in this particular one, we should have position for software development services for $9,000, and it's for $90,000. So for one person it's good, for another it's not good. And there's one funny thing about invoices, that after they were issued and sent, you cannot modify them. This is how accounting works. So for example, you can see it's $90,000. But accountants are pretty smart guys, and they figure out that, yeah, we can make mistakes. They figured out that we can create a special type of document named credit note. And credit note can have negative positions. Like here, you can see that we have position for minus $81,000. So we can imagine, okay, how complex it can be to create such functionality. So Emily found that implementing credit note functionality required effort of 3 teams. It required changes in 7 microservices, 3 months of work, and result, 2 PDFs. Pretty expensive for 2 PDFs, we'll say. So she started to wonder, what's really wrong here? And she did some kind of reverse engineering of this feature. So, and started to think, okay, what is making us slower, and what decisions being made did. So at the beginning, okay, they need to develop features, but probably it's making implementing those features more complex because, well, the product is complex and we cannot do much about that. It's financial domain. Who worked with financial domain is not laughing that much after it. And but it's essential complexity. We cannot really do much about that. The second thing, hiring more people, well, didn't help that much. But from other side, at some scale of product and complexity, at some point we need to hire more people. So probably it's not the place where the problem is. But the third place where she found the problem is how Being Made is building approaches, building microservices. And she found that Being Made took one of the worst possible approaches to microservices. So they took the previous monolith, they get the database tables, and put each table to a separate microservices. And to make it worse, they assigned it to some artificial teams. Great idea. So this is how the architecture looked like about the microservices migration. So we have stuff like invoice positions, invoice validator, configurations, calculations, addresses, and invoice printer, and invoice audit, and discounts and taxes. And with yellow one, I marked services that they changed. So you can imagine why it took that much time. But let's wait for a second. Wasn't it one of the microservices promises to simplify our lives by splitting bigger problems into smaller? And it's true, but only as long as you are splitting things that are not coherent. If you try to split things that are closely related, you will end up with accidental complexity. Do you remember this chart? This is exactly the place where they ended up. And maybe each service will be a bit less complex, but overall solution will be much more complicated, and it will be much harder to add new features and modify there. And what's the solution for this problem? Well, the solution, I know that it may be a bit controversial. And I know that in Prague, you have long tradition of idea of defenestration. Fortunately, I know that those windows are not opening safe, so thank you. But The idea is to do microservices. Yay. And before thinking that I'm crazy, I can say two things. I did it multiple times in my life and it helped a lot. And think again about this unproductive effort to, do this, well, do this change, adding this simple feature, and you need to, three teams need to work on half of the work. It's just a lot of unproductive effort that doesn't lead to anything. So example architecture can look like this, for example. So you can have invoice service and addresses service, for example. But probably some of you might think that, okay, nice, we can join everything to one to do those two services, but this one invoices service will be pretty complex. So how to deal with that? And ladies and gentlemen, this is the time to give a warm welcome to domain-driven design. That may be pretty useful here. So I define domain-driven design as a set of techniques that helps build complex systems that are maintainable in long term. And there are a couple of things that we can take out of this definition. So the first one is that domain-driven design is not a good tool for simple projects. So for example, if you are building a project like BillingMate, when you have complex financial domain with a lot of complex rules, yeah, DD may help you. But if you're building a CRUD application, it will just make stuff more complex than it needs. The second thing is that domain-driven design is not the best fit for proof of concept projects or some throwaway projects. And for a simple reason. Domain-driven design requires some initial investment at the beginning of the project. And if you would throw this project away after a month, it will be just not enough time to pay the investment back. And the third thing is that domain-driven design is also a pretty unique technique because it helps you holistically with the project. What does it mean? So it's not only programming technique that tells you how to code in some way, but it's also telling you, for example, how you can create your architecture, how you can split your microservices, or even how you can gather requirements, or for example, ask some important questions like, why we need to build that? Because sometimes we are also requested to build some stuff that nobody will use because nobody asked this simple question, why somebody will need to use that? So domain-driven design can help with that. But we are in the Go meetup. So I want to show you today 3 patterns from domain-driven design that you can apply to code. So I have for you 3 patterns that, in my opinion, you can even use tomorrow for your project if it's a right fit. So let's not waste time. Let's start with the first pattern. The first pattern is telling us to always keep a valid state in memory. And this is very simple, but very powerful idea. So let me explain it in example. So let's take an example of invoice. So this is how a simple invoice model can look like in your CRUD application. But at the first sight, it can look like, yeah, it looks fine, nice model. But if you think for a while, it have one big downside, especially for more complex projects. You can modify it in any way that doesn't make any sense. Example, so let's imagine that we can have add to this invoice position that has negative quantity, negative value, and at the end, it doesn't update the total amount in the invoice. So it can break totally the model of how invoice works. So we should not use something like that. And it's not a big deal for smaller application because, okay, if you have, I don't know, 3 people that are maintaining the service, they probably should know that they shouldn't create invoices that have negative quantity with negative value, etc. But if, for example, with this project, this service, you have 20 people that commits to that, it's much harder to share this knowledge and ensure that nobody will do such crazy stuff. And it's interesting because in microservices, it's not that big problem because when you have microservices architecture, the API layer of your service is ensuring that you cannot do that because, for example, you cannot change total of the invoice because API is not exposing that. You cannot, for example, set negative position in the invoice because API doesn't allow you to do that. So it's interesting that with microservices, it's kind of solved without us thinking about that. But today, I have a special technique for you that is 62 years ago. I needed to write it down because it's that crazy that it's 62 years ago. And it's allowing you to achieve the same thing that you can do this, stuff with microservices that people that cannot change your models in the wrong way, but without microservices. So, you can simplify your code a lot. And it was done first time in programming language Simula from 1965, so pretty old one. We talked earlier about the old ideas, how great they are, and they are still pretty valid. And the magic technique is named encapsulation. Hooray! So this is how our invoice can look like with encapsulation. So you cannot no longer change the total amount of the invoice because it's not there. It can be calculated dynamically. You cannot also create artificially invoice that doesn't make any sense, and you cannot also artificially modify that because invoice positions are encapsulated. If you are creating new invoice in this case, you need to have constructor for this invoice, and this is the only way how you can create your invoice. The same goes for invoice position. So in this invoice position, you can ensure that quantity is non-negative, value is not negative, and thanks to that, you are sure that you never have in your memory entity that is not valid. So it's not possible to have invoice position that is not valid because it's just technically not possible to create that, like with microservices in some way. And the only scenario when invoice position or invoice can be invalid, it's zero value because you can always create zero value of the invoice. So for example, if you're adding a new invoice position, so you can no longer add it like you want. So again, this invoice position that you have here, it needs to be valid because it's no other way to create that. And you need to also ensure that it's not zero, because if it's zero, it's zero. So it's probably not valid. And some of you might ask, okay, how it really helps? And again, we're now talking about more complex projects with more people with complex logic there. So in these cases, it's giving you a lot of confidence when you're doing changes in your code, because when you're doing those changes and you are using public API, you're totally sure that you're pretty sure, like with microservices, that you are pretty sure that you're not doing anything that is disallowed. Of course, there may be some bugs in the code, but in general, the chance of doing something not allowed is much, much slower. Also, doing code review of that is much easier because if somebody is doing code review and he see that, okay, you're using public API, it's legit. If you're using Reflect to change total value of invoice, I would probably ask some awkward questions why somebody is doing that. So it's helping with that a lot. That was the first idea. The second idea is to make the domain package agnostic from the database. And how? Probably most of you seen in your life some complex code that is super legacy and have methods that have 8,000 lines of code. And usually they look like that. So you have database logic that is mixed with your domain logic. And if you work with this code, you probably know that it's usually the favorite code to touch because you totally know how it works, it's easy to test, etc. It's not that simple. And that's why, again, it's quite simple idea that I think in Rush we are often forgetting about that, but solution for that can be, let's split that. So we can have our domain code that is separate from our database logic. And solution for that is also quite simple. Maybe some of you heard about that. And the solution is the repository pattern. So the idea is to define all the operations that we need to be able to do on the database and define interface for that on the domain and kind of hide the implementation of that from the real implementation. And some people think that it's quite cool because you can easily replace database. And yeah, that's true that it's helping with that. It probably I made it twice in my life, but this is not the reason why we are doing that. But if you feel that you can replace your database easily and it will not affect your code, it means that your code is kind of independent from the database. And nice thing that you have out of the box is that you can write stubs of the database pretty easily and cheaply. So this is, for example, how in a more implementation of create invoice draft can look like. So it's probably, I don't know, 8 lines of code. And I know you have Docker container, and you can run it locally. And yeah, I totally agree. You should have such tests. But from other side, if you have if you have hundreds of test cases to run, it will be just slow with the Docker that is running locally. So if you have a super complex logic and a lot of test cases to test, having such in-memory stubs is super nice. And one nice thing is that, if what I recommend is to not use any mock generation tools here, because probably some of you tried that, but my experience is that those tools are usually not that nice to use as they should be. So again, it's nice tip to be able to write it by hand. I don't have that much time to show you some example implementations, but in the presentation of materials, I will show you, there will be the link to some production grade implementation of this, how you can implement that, because it has some quirks, how you can do that. For example, Miłosz also writes some nice article about that. But again, it's probably topic for another presentation, but no worries, it will be in the materials, so you can check there. And time for the third rule, that is saying us to reflect your business logic literally in the code. And it means that if you have some structs, names, methods, names, etc., it should reflect the language that people are really using in kind of real life. So let's take example of invoice again. So if you show this invoice model to an accountant, and if you say that, okay, for example, this invoice have a buyer, seller, issue date, or number, he will totally understand what's there. What does it mean? Because this is using exactly the same terms that the kind of accountants are using. And I know that it may sound obvious, like, okay, why we should not use the same language? But accounting domain is kind of, let's say, easy example here, because accounting has probably 3,000 years already, and the language is also pretty well set. But for example, e-commerce, marketing, and some newer domains, it's not that easy. That sometimes this language is evolving with time. And I think working with financial domain at some point showed me how, so it was a bit cheaper, let's say, to use this domain language in the code, but it showed me that it just saved us a lot of time. Because usually we are not thinking that we may be often talking to non-technical people about some terms, and they may not really understand us because they're using different names for some stuff, and it's hard to collaborate. Or sometimes we need to do some in-head translation of some terms from our code to some business people because we're using totally different terms. So the lesson from that will be that it's worth to also try to keep this language pretty up to date, because it requires some effort, but it will pay you back. And one good example is when, for example, you are implementing new features. So we can take, again, credit note example and how requirements to credit note can look like. So we can say that credit note is a special type of invoice. Invoice position value can be positive and negative. Buyer and seller need to be the same as referenced invoice. And we can take these requirements to the code and use exactly same terms, and later it's much easier to even validate with some domain expert. Of course, not every domain requires domain experts to work with, but for example, financial domain often requires, because I'm not an accountant, I don't know how credit notes should work, but it's useful to, for example, sit with such person and go with this person with some help over the code and try to validate if it's work. And it happened to me a couple of times, and it's very useful, and it's making our implementations easier and validation much easier, and also fixing some bugs. And yeah, it's kind of pretty cool. There were 3 simplest parts of domain-driven design that I can believe that you can use pretty quickly in your projects. But, well, it's still top of the iceberg of domain-driven design. But I hope that it will give you some inspiration to explore this topic further, or just use maybe those patterns that you've seen here and see if it works for you. But before going to the end, I wanted to do one thing, because I know that in Go community, there are a lot of myths about domain-driven design. So you already seen a bit how domain-driven design, the real domain design can look like in Go. So I wanted to play a quick Mythbusters game with you and try to demystify the couple myths about domain-driven design. The first myth that I often hear is Go is a simple language. You should not use any complex pattern like DDD. The second one is saying us to DDD makes code more complex and harder to read. The third one is saying us Go is not a good language for business logic. And in my opinion, they have all one thing in common. They are doing generalization. So they can be both true and false, depending on what project you will try to apply them. Again, the thing that I mentioned a couple of times, if you try to use those ideas for CRUD application, it will make it more complicated. It will make it less readable. But if you try to use it for cases like Invoice Invader or any more complex domain, it will help you a lot. It's also important to mention that it's not like you need to use domain-driven design in entire project. You should find the places in your projects that are the hardest to work on, and where it will give you the most benefit. But rest of the application, it can be still simple CRUD, and it will be more than fine. So let's try to maybe update those myths a bit. So probably first one can be Go is a simple language. You should use domain-driven design only for complex projects. So again, no CRUD, only for complex projects. I'm mentioning that because I know that a lot of people are doing some kind of CV-driven development. They're trying to use all the techniques that they see to just have later in CV. And later, you can see some monsters that is trying to do domain-driven design, but it's just making it more complicated than it should be. And it's making some kind of bad PR, let's say, especially that, domain-driven design, the idea have 20 years already. So it went through that many iterations over that many people. So bad things happen sometimes to this. The second thing can be probably domain-driven design makes code more complex and harder to read if you use it for simple domains. So again, you've seen the code, for example, for the invoice. So I'm not sure what is your opinion on that, but in my opinion, it made this code pretty readable, and it was readable how it works, and it was much easier to work with that. Also, getting rid of this database logic out of this code, also, it helps pretty a lot. And the third one, in my opinion, it's always false. So I write in Go already for 8 years, and it's so far my favorite programming language that I code in. And I also work in a couple complex domains, and I cannot imagine using any different programming language for that, because Go just does the good job. And yeah, I believe that it just fits to domain-driven design nicely, because it's a simple language and it's allowing you to express this logic nicely in your code. So again, this was the top of the iceberg. There are still a couple more nice things that domain-driven design can help you with, like modularization, how to split microservices with some architectural stuff. But we'll not touch it today, unfortunately, because again, it's a bit more complicated. But we already touched some of that on our blog, and we plan to touch a bit more in the future. So I recommend it to join our newsletter, because you will be up to date. And I guess that those things may be useful for that, because we found how many problems we had with that earlier, and we found how domain-driven design helps us in multiple situations already. Even if you don't think that, okay, you need domain-driven design for some reason because you didn't work in any complex domain. So no, maybe you'll work at some point with some project that will require some more advanced patterns, especially that, I know how job market looks like now. I mean, it's hard to find a good job, but I also know this problem from another side. It's also hard to find good engineers that are able to write complex domain code. And it's also very often the case that the companies that have a lot of money have also complex code, and they will be more than happy to hire some people that can handle that and throw money to these people to make them more money. So this is how the deal looks. But again, domain-driven design is pretty helpful for that. And if I've seen some people that were kind of known those patterns properly, it was some big advantage compared to many candidates, because a lot of people doesn't get those ideas well. Especially that I know that a lot of examples about domain-driven design in the internet are totally wrong. I would say probably 80% of Go examples about domain-driven design were wrong before AI. Now it's probably even worse, because AI is creating more wrong examples. So find the good examples. All right, so this is the QR code that I promised. So you can scan that. So you have slides there. I forgot to mention that there's also a link to our project that we created. So it's using domain-driven design, CQRS. It's showing how to use repository pattern. It's pretty popular because it has 5,000 stars on GitHub, so probably it's even useful for somebody. So I recommend it, especially that you can run it locally, play with that, break that, whatever. So I know how it's useful, to have something that you can play with and see how it's working on the real project. It even have front end. Trust us, it was painful for us to do that, but we made that. And yeah, that will be everything for today. Thank you for your attention.